Welcome back to Measuring for Dollars. Brought to you by Baby 04.
I'll take increments for 100.
The answer is unit to measure the diameter of an atom.
What is an angstrom?
Yes, still your turn.
I'll take hurry up and weights for 200.
Word used to describe weight of precious stones.
What is a carat? I'll take potluck for 500.
Ooh, a 20-letter word for a cool science show. 20-letter word for a cool science show. Anyone? Oh, sorry. What is...
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
How far is it from here to here? How much does the television set you're watching weigh? And how many years old are you? See, we measure things all the time. That's how we compare one thing to another. Measuring things is how we understand the world. And especially, it's how we understand our place on it. Measuring things allows us to figure out how long it takes to get from one place to another. If we didn't measure things, everything we build would fall right down. The better we measure, the better things fit. Take a look at this. It's our very wide chasm of science. We want to build a bridge from here to there because the chasm is too far to jump across. And besides, down there is a raging river infested with vicious alligators. Well, it's a representation. So, to build a bridge, we need to measure it. When we measure things, it's as though we project a grid on the world. So we can measure this empty space with this 2-meter stick. And it's exactly 194 centimeters across. So, we want a bridge at least 194 centimeters long, but not too long because we don't want the bridge to run into these very dangerous high-voltage power lines, which are a little over 2 meters away. So we'll make a bridge that's 194 centimeters. Well, here's one we prepared earlier. Let's measure it. And it's 194 centimeters. So let's lower it and see if it fits. Here we go. See, we knew it would fit because we measured it first. Now we can cross the chasm without fear of the alligators.
Guess you made a little miscalculation there, Bill.
Just kidding. Oh. Measuring allows us to make things that fit, and we can understand the world. We don't come up short! We can measure all kinds of things that are going on in the human body. Our heartbeat, how much oxygen is in our blood, even our brain waves.
Very interesting.
That's how we understand what's going on inside. Now, the more we want to know, the more measurements we make. Every post, every beam, every pillar, every pipe, and every wire is planned. We know where they're all going to go because we measure them beforehand and we measure them as we put it together. The more carefully we measure, the more accurately we can make things and make things fit, like airplane parts. First, we line the machine up. Then it can find its way to anywhere it can reach within half the thickness of a sheet of paper. We can make each part just exactly as heavy as it needs to be. That way we can make planes that fly farther and faster and use less fuel. The better the measure, the better the plane. Here we go. Okay, once we're flying, we use these gauges and instruments to keep track of things we need to know, like how fast we're going, how high we are, how much fuel we have left. That way we can measure things and land and fly planes safely every time.
Oh boy, the nose is too high. I'm almost out of fuel.
Bill.
We're not going fast enough.
Bill,
Whoa, we're losing
slight
left.
overcorrection, Bill.
Pull back.
Bill.
No, forward. No,
Bill.
Great moments in measurement. A long time ago, people used to measure things with their own body parts, like feet. But just whose foot was 1 foot? Later, it was the king who declared that his foot, the royal foot, would be the foot that all feet would be fitted against. It was the standardization of the foot, and it was quite a feat.
Humans are about this big. So we've always wanted a unit of measurement about this long. And we want it to be the same for everyone. We want it to be a standard. That's why it's hard to use something like a foot, because not everybody has the same size feet. So what we did is we looked at the Earth and we divided the distance from the North Pole to the equator in tens, 10 million times. And we got this. It's a meter. We use tens because humans have 10 fingers. Now you can keep going. You can divide a meter by 10 and 10 again, and you get centimeters. There are 100 centimeters in a meter, just like there are 100 cents in a dollar. You can divide it by 1,000, and you get millimeters by 1,000,000, and you get micrometers. It's easy. With a meter, you can measure just about anything. This microphone is about 32 centimeters long.
What?
It's the metric system. It's easy.
What?
I said it's easy.
What?
The man with the accurate touch. It's the power of
007. Point 007.
If you're going to go up against the more sinister elements, you're going to need one of these, the ultimate measuring device.
Does it have a death ray?
Please try to be serious, Point 007. It measures temperature, length, time, and if you stand on it, it will even indicate weight.
That's fantastic. All the things humans need to measure.
Precisely. Please try to bring this one back intact, will you, Point 007?
I'll do my best.
A bulb from Baltimore screws into a socket in Seattle. A battery born in Boise can relocate to a radio in Reno. A cap fabricated in Fresno fits on a fizzy container of soft drink. Maybe in your hometown. But see, they all fit because they've been measured. It's fabulous.
Bill, don't touch.
Citronella.
She's gonna start a revolution. When she finds the solution. Yeah, when she launches, she's pure old-faction action. Even flies stand by for Citronella Jones. Tonight's episode, just about a meter.
Federal Agent Citronella Jones, Bureau of Weights and Measures.
Come on, what I do? I'm clean, honest.
Honest! Sniffly, you don't know the long and short of the word. Just as I suspected. Counterfeit meter sticks. Hasn't anyone schooled you on the importance of standards, Sniffly? You can't just put random markings on there and call it a meter stick. It just doesn't measure up.
Oh, what does it matter, Citronella?
Freeze! No! I want you 0 degrees Celsius, mister. Same old story. I give you a centimeter, Sniffly, and you take an astronomical unit.
Oh, Citronella. Come on, give me a break, will you?
We use standard measurements. A meter in America. C'est la même chose qu'une mètre en France. Or a meter in Britain. Or even a meter on the moon. It's all the same.
We don't need much to measure just about anything. Please consider the following. We can measure the width of this board. It's 1 meter. We can also measure how high it is. It's also a meter. We say we're measuring the area of the board. It's 1 meter by 1 meter, or 1 square meter. Now, this board isn't as wide. It's only half a meter. But look, it's 2 meters long. Well, 2 halves make 1. So even though it might not look like it at first, this board and this board have exactly the same area, 1 square meter. We measured it, and all we needed was a measurement of length. Now take a look at this. We can measure the area of the end of this cube. It's also 1 square meter. But we can measure it this way as well. That's how high it is. When we do that, we're not measuring its length, but how big it is, how much room it takes up, its volume, and it's 1 cubic meter. So whenever we want to say how much of something we have, all we need is a way to measure length, like a meter.
Bill, you can lose the hard hat. I'll take care of it. Thank you.
Now here's the thing. Everyone has agreed that a tenth of a meter by a tenth of a meter by a tenth of a meter is a volume called a liter. Now, on top of that, a liter of water
Very nice. Careful.
See, a liter is exactly 1 kilogram. So if we want to know how much mass something has, how much it would weigh, all we need is 3/10 of a meter and water. It's easy. Like when you measure a distance, all you need is a meter. 1,000 meters is a kilometer. And 1,000 liters, well, that's a ton. Well, thank you for joining me on Consider the Following.
Try this. Make a hodometer. Take a ruler and draw a line that's 15.8 centimeters long on a heavy piece of paper.
Wait a minute. What's that? 15.8? That's 16.8. Uh-oh.
Oh, you started at 1. Okay, I got you.
Use a tack and a pencil to draw a circle with the paper. Make 2 of them and cut them out. Here's 2 I prepared earlier. Use a brad to make a hole in the middle of each circle. Tape them together. Now attach the cardboard to a handle, like this. Use a scrap piece of cardboard as a guide for your wheel. Draw 2 arrows on your hodometer. One here, and one here. The outside of the circle is exactly 1 meter around.
Uh-huh.
Start with the arrows lined up and roll your hodometer. Every time the arrows cross each other, you've gone 1 meter. Measure things.
Good afternoon, you measure it frames.
Hey, what's up?
We have frames, you measure.
Hello?
Huh?
Hello, yeah. Yeah, I'm looking for a frame.
Yes, what do you need?
98 centimeters by 68 centimeters blue aluminum frame, please.
Oh, yes, we have a very nice...
Yeah. Uh-huh. Yeah. Uh-huh. Mm-hmm. Yeah. Gotcha. Yeah. Uh-huh. Yeah. I can communicate the size of my poster and get the right frame for it. And I know it'll fit because I measured it. Yeah.
Measure a soccer field. With your hodometer, you could, dare I say it, measure the world!
This is a thermometer. It has a liquid metal inside, mercury. It expands when it gets warm, and it contracts when it gets cool. And it expands and contracts the same amount each time. So we can use it to measure temperatures very accurately. Now, this is ice. It's cold. You can feel it. This is boiling water. If you touch that, you get burned. So an astronomer named Anders Celsius came up with the idea of using a thermometer. And he called the temperature at which water freezes 0 and the temperature at which water boils 100. So there are 100 degrees between ice and boiling. And to this day, it's called the Celsius scale.
Now we'll have occasion to make temperature measurements. So we need a standard of temperature, too.
Thermometers are cool.
Oh, I mean, they're hot.
Ah, perfect. The things we measure most are length.
Mass.
Time.
And temperature.
The things we measure most are length.
Every time of day, everything you weigh, every mark you make, every temp you take is a measurement. Human beings compare. There's a standard there. Temperature you take, time and mass and length, standard measurement. For length, I consult a meter stick. I use a gram to define the mass of grit. If I use liters, I find the volume quick. Across the world, we all use the simple trick. Keep using standard measurements. Standard measurement, time and mass and length. Temperature you take, standard measurement.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some global positioning calibration algorithms to optimize. See ya.
There's latitude and longitude. And the Earth spinning underneath it.
Produced in association with the National Science Foundation.
And we got this. It's a meter. We use 10 because humans have 10 fingers. It's easy. History books would be a lot harder to understand if humans hadn't discovered ways to measure time. It all starts with days, because every day is divided into a day and a night. Humans discovered that they're caused by the spin of the Earth. The Earth is like a giant clock that goes around once a day. Now, there are 365.25 days in a year. So humans invented calendars to keep track of days. And we invented clocks to divide days into hours, minutes, and seconds. By measuring time, humans can record history, do things on schedules, celebrate birthdays, and just be on time.
Time's up.